Welcome to Part 1 of Yamaha Outboard Rigging. This first video in our three-part series covers procedures for outboard engine installation. The second installment will take a look at component installation and rigging. The third segment concludes the series with engine pre-operation and pre-delivery inspection. The topics covered in this video include receiving an outboard engine, determining boat centerline, measuring transom centerline, checking hull design, drilling the transom, lifting the engine from the crate, transom bolt arrangement, determining proper engine height, tie bar measurements, water pressure and trim angle verification. Yamaha's goal is to exceed the expectations of our customers. We are committed to creating the most dependable product in the industry. During manufacture, each outboard engine must pass rigorous quality control specifications along with a running engine test at the factory. The final step in ensuring quality to our customers is up to you. It is your responsibility to see to it that all outboard motors and boats are rigged properly and set up safely. Boating is a pleasure sport, and nothing is more frustrating to our customers than having to bring their new boat back to the dealership for repairs due to a failure. The rigger can help avoid this by making sure that the job was done right the first time. For this reason, we recommend that you utilize all the service literature, training, and service tools available as resources to you on the subject of outboard rigging. It's always a good idea to review all instructions that come with a motor. The Yamaha Rigging Guide has many valuable tips that just might save you hours of work or from making a cosmetic error on the customer's boat. Yamaha outboard engines are shipped to you in crates sent direct from a Yamaha warehouse. These engine crates are all inspected before they are loaded onto trucks. Shipping companies will refuse to accept a crate if damage is found. And that is why every crate is inspected before they are loaded onto trucks. When a shipment arrives at your dealership, it is very important that you inspect the engine crates to determine their condition after transportation. Do not sign for the engines until your inspection is completed. Any damage must be noted on the shipping company's bill of lading while the delivery person is still present. Outboard crates are well marked for forklift lift points and the center of balance. Observe these and other marks whenever handling or moving any crates from Yamaha. There are three different types of outboard crates: styrofoam, styrofoam with wood subframe, and metal. Smaller engines, 8 horsepower or less, are packed in a container made of styrofoam inside a cardboard box. The 3-cylinder and smaller 2-stroke, along with the 15 horsepower and smaller 4-stroke engines, are shipped in a styrofoam wood subframe crate. When receiving either of these two types of crates, inspect the outer cardboard for any tears or punctures. Examine the corners of the crate for any signs of compression. Then, carefully check for styrofoam punctures or any breakage in a wooden subframe. If damage is noticed in these areas, an internal crate inspection is required. The V4 and larger 2-stroke, along with the 20 horsepower and larger 4-stroke, are shipped in a metal crate. Look over the outer cardboard for any tears or punctures. An easy way to check if the crate has been dropped is by seeing if it can be rocked while resting on a flat concrete surface. If a concrete surface is not available, visually inspect the lower L channel for any kinks or bends. If damage is noticed in these areas, an internal crate inspection is required. Remember, once your inspection is completed, any and all damage must be noted on the shipping company bill of lading. Engine and boat applications can vary from a single outboard to twin or triple installations. Your rigging knowledge is depended upon to help match the proper boat and engine horsepower for the customer's application. Engine mounting will also vary from transom mounting, mechanical jack plates, hydraulic jack plates, or engine brackets. No matter what type of engine application you are attempting or mounting you are using, the first step in rigging is to find the center line of the transom. This is a line drawn that runs perpendicular to the waterline halfway across the transom. There are a couple of different ways to find a transom center line. The most common method that we will demonstrate requires the assistance of a helper, as well as a tape measure, straight edge, level, and a wax pencil. Where you measure from to determine the transom center line is critical. Because of boat manufacturing irregularities, the center of the upper deck is not always the center of the transom itself. If you use the top of the transom to establish a center line, you may be off by an inch or more. The most consistent surfaces for measuring the transom center line are the chines and the strakes. Be careful not to confuse the two. Chines are where the sides of the boat meet the bottom of the boat. Strakes are the lifting pads on the bottom of the hull. Start by holding one end of the measuring tape at the bottom corner of one of the chines. Measure the entire distance across the transom to the chine on the opposite end. In our example, this measurement is 83 1/4 inches. Now divide the total length in half to find the center of the transom. Make a mark on the transom with the wax pencil at this midpoint of 41 5/8 inches. Move the measuring tape down to a set of lift strakes and measure this length. Divide this length in half and mark the transom with a wax pencil. Now you have two marks on the transom. If possible, find another set of lift strakes and make a third centerline mark. We recommend the use of 3 reference marks. If the boat does not have 2 sets of lift strakes, 2 marks will suffice. Take the straight edge and align it with the marks. Draw a line that runs all the way up and down the transom. Recheck your measurements. If you are rigging an aluminum boat or a pontoon boat, you will have to use another method to mark the transom centerline. You'll notice that our pontoon boat has already been rigged. We've removed the engine for demonstration purposes. The engine pod on a pontoon boat does not have strakes like a fiberglass boat. Most aluminum boats don't have strakes. If they do, they may not be true on the bottom. However, the engine pod does have edges to measure from. To find the center line, measure along the edge of the engine pod and make 3 marks that are the same length down on each side. In this example, our first set of marks on both sides of the pod are 2 inches from the bottom. Our second set of marks are 8 inches up, and the third marks are 12 inches up on both sides. Check the distance across the pod at the top edge marks. On this example, our measurement is 22 inches, which divided by half is 11 inches. Make a mark with your wax pencil at 11 inches. Now measure across at the other edge marks on the engine pod. Divide the total length in half and make a mark at the halfway point. Referencing these 3 marks, use your straight edge to draw the center line of the pod. With an aluminum boat, measurements are taken from the chines up. Then, like the pontoon boat, check the distance across the transom and divide it in half to get the center line. Once the vertical center line is drawn on the transom, the next step is to double-check the measurement distances to verify that the vertical line is straight. The transom center line has been determined. At this point, if the boat is to get a jack plate or engine bracket, you will need to install those per the manufacturer's recommendation prior to mounting the outboard engine. This fiberglass boat, already marked with the transom center line, is going to be rigged with a single engine. We're almost ready to drill the transom. But before we do that, let's look at how to measure the center lines for mounting multiple engines on this boat. The first step is to know what engine model you're going to install. For this exercise, we are going to be installing F225 engines. When mounting more than one outboard, you will need to determine the minimum centerline distance between the engines. This specification is the minimum clearance allowed between the engines to prevent the engines from rubbing or hitting each other. Note that this is the minimum clearance, and you cannot mount the engines closer than this specification. Most mounting applications will exceed minimum specifications. Information on the minimum centerline can be found in several places: the Engine Service Manual, the Engine Service Guide, and the Rigging Guide Service Data Book. If the service support information has not been received for a new model, your dealership can always call Yamaha for assistance. For our F225 engines, the minimum centerline distance is 28.5 inches. On a twin-engine application, center lines for the port and starboard engines will be drawn on either side of the transom centerline. Measure from the edge of the boat to the transom centerline. Our minimum engine dimension is 28.5 inches, and half of that is 14¼ inches. Measure 14¼ inches away from the transom centerline on both the port and starboard sides. Mark the transom in 2 places on each side. With your straight edge, align both marks on the port side of the transom centerline and draw a line from the top to the bottom of the transom. Repeat that same procedure for the starboard side. Now the transom for twin engines will have 3 vertical lines. Recheck your minimum engine centerline dimension at several points. Measure between the 2 outside lines. Make sure the distance is correct. Also verify that the measurement from the top of the transom to the bottom of the hull does not exceed your engine shaft length. For example, since we are mounting 25-inch shaft length engines, we will require the length to be 25 inches or less. If the distance from the top of the transom to the bottom of the hull is longer than the shaft length of the motors being mounted, then the engine center lines will need to be moved out. For a triple engine application, finding each of the center lines is done a little differently. The 2 engines on each side now have to leave enough space to clear the 3rd engine in the middle. Let's take our same F225 engines with a 28.5-inch center line. The center engine will mount on the transom center line just like a single engine application. You will need to measure the full 28.5 inches from the transom center line for both the port and the starboard engines. Mark 3 lines on each side. Now with your straight edge, draw a line from the top of the transom to the bottom. Your triple engine transom will have 3 vertical lines. While it appears similar to the twin engine transom at first glance, it's actually different because the lines are farther apart. Again, double-check your measurements at several points. With the proposed center lines marked on the transom, the next step is to inspect the hull design, the lifting strake location, through hull location, and transducer locations. These 3 components have an effect on water flow under the hull. The engines must run in clean, undisturbed water for engine cooling and performance. Disturbed water could adversely affect performance and result in propeller slip, or even cause catastrophic engine failure. Lifting strakes come in a variety of widths, lengths, and designs. Even strakes that end midship on a boat can have an effect on an engine. Keeping in mind water flow across the V-bottom, it is best to mount engines between the boat strakes. Through hulls can range from a water inlet discharge to a transducer and could account for anything mounted through the bottom of the boat or on the transom. It is best to ensure that you do not have any sort of through hull or transducer within a 24-inch center line, 12 inches on each side, of the engine's lower unit. Nothing within this zone can be in front of the engine. Make sure that this area all the way to the bow is clear of any through hulls or transducers. If there is a strake, through hull, or transducer that would interfere with the water flow to the lower units, then the engine center lines will have to be moved out equally. The engine center lines have been marked on the transom and double-checked. We have ensured that there are no obstructions from the hull that will interfere with water flow. Now we are ready to drill the engine mounting bolt holes on the transom. You will need a drill, a 1/2-inch or 13mm drill bit, carpenter's square, and a large C-clamp. Another required tool is the Yamaha engine drill fixture plate, available from your authorized Yamaha special tool supplier. This drill fixture assures a proper match between the transom brackets and the mounting holes you drill. It allows riggers to position mounting holes simply and correctly the first time, every time. The drill fixture has 10 different drill hole locations. The inner 4 are used for most 2-cylinder and smaller engines. These drill points are used when you want to bolt the engine to the transom. These holes require a 3/8-inch or 8mm drill bit. There are 6 outer drill holes on the drill fixture. Only 4 are used for the T25 up and the 35 engines. These drill points require a 1/2-inch or 13mm drill bit. You will not use all 6 for each engine. The 2 center drill points will not be used at all. The top 2 and bottom 2 are the most common bolt drill points. The center of the drill fixture has 2 diamond shapes. One is near the top and the other near the bottom in the center of the plate. These 2 openings are used to indicate the center line of the drill fixture. Place the drill fixture on the transom and align the diamond top and bottom corners with the engine center line. Using the large C-clamp, secure the drill fixture. Once you've done that, double-check to ensure the diamond corners and engine center lines are still aligned. Verify the height from the top drill template hole to the bottom of the transom. It is recommended to measure the distance from the second mounting hole to the anti-ventilation plate on the engine. Since we are mounting an F225 engine on this boat, it will require us to drill 4 1/2-inch or 13mm holes. We will use the top 2 and the bottom 2 drill points. Before drilling, be sure to hold the drill perpendicular to the transom. Most transoms have an angle built into them. If you drill through the transom without being perpendicular, you may cause the engine to be mounted incorrectly. This will also damage your drill template guide holes. Using a carpenter's square helps make sure you hold the drill perpendicular. Drill all 4 holes for this engine. When you are done, remove the large C-clamp and drill template. Verify that the holes are free of debris and burrs. Clean up as needed. On multiple engine installations, repeat this procedure for each outboard. It's time to prep the engine. Some disassembly to the crate is necessary before it can be removed. With styrofoam crates, the engine will simply lift out of its crate. The styrofoam wood crates will need to have the top cardboard cover and top styrofoam lid removed, exposing the engine. Metal crates will require you to remove the cardboard cover and unbolt the top frame and side supports from the lower frame. Do not unbolt the clamp bracket or skeg support rod. Remove the top cowling from the engine. Look for the lifting points. Some engines will have one lifting point, while others may have 2 or 3. Engines with multiple lift points must have the lifting harness attached to each point. For the next steps, make sure you use equipment that is adequately rated and properly maintained. The engine will have to be removed from the crate with an engine hoist. Be aware that this procedure is not a one-person job. Get help. Hook up the engine hoist to the lift harness. Connect the harness to all of the lifting points on the engine. Now, carefully lift the engine while it's still attached to the lower frame of the crate. This will stabilize the unit to avoid any damage. With the engine being supported by the hoist, you can unbolt the crate's lower frame. Have help with holding the frame to avoid injury. Make sure the engine is hanging as vertically straight as possible while it's being supported by the hoist. We can now prep it for installation. You will notice we have several warning tags hanging from various points on the engine. Take the time and read each of these tags. These tags contain important safety information concerning the engine you are about to install. It is your responsibility to ensure that all the warning tag instructions are adhered to. Shipped with the engine is a hardware package. Inside the hardware package, you will find an owner's manual, mounting bolts, and where applicable, steering components, battery cables, and a fuel hose. The hardware package contents will vary depending on the engine model. With the engine removed from the crate and the contents of the hardware package at hand, we are ready to install the mounting bolts. In this engine's hardware package, you will find 6 mounting bolts, 2 that are longer and 4 that are the same length. We also have 8 nuts, 8 small flat washers, and 4 large flat washers. Before you begin, be aware that there is a specific assembly procedure for this hardware. We will start with the bolts. This engine only requires 4 bolts for mounting. The longer bolts are supplied for use on some thicker boat transoms. Choose whatever combination of bolts that will properly mount the engine with plenty of thread engagement for the nuts. The engine mounting bolts must be sealed prior to installation. It is best to use a good marine-grade sealer like Life Caulk, marine silicone, or something equivalent. Keep in mind to use a sealer that will allow for easy engine removal if needed. The mounting bolts will have a specific washer placement. Here is one of the top mounting bolts. The small flat washer is installed first, then the large flat washer. Place a generous bead of sealer around the center of the bolt. Now install the bolt in the top mounting hole in the transom with the head of the bolt in the engine well. Push the bolt until the thread end is flush with the outside of the transom. Repeat the same washer configuration, sealer application, and installation for the other top mounting bolt. On the lower engine mounting bolts, place a small flat washer first, then the large flat washer. Again, be generous with a bead of sealer around the middle of the bolt. Install the bolt in the lower mounting hole with the head of the bolt inside the boat. Push the bolt all the way through the transom until the large washer is flush with the inside of the transom. Repeat the same process for the other lower engine mounting bolt. Clean off the transom prior to installation. Before we mount the engine, let's take a little time to discuss an important consideration whenever you rig an outboard: engine height. Engine height is determined by the height of the anti-ventilation plate relative to the bottom of the boat. Whether you're doing a transom mounting or an engine bracket jack plate installation, it is easiest to check engine height with the boat and the engine at 0 degrees. Using a straight edge, such as this 3-foot level, make sure that both the boat and engine are level. Set a straight edge off the bottom of the boat and bring it out by the anti-ventilation plate. Run a tape measure from the straight edge to the anti-ventilation plate. This measurement is the height of the engine. When mounting an engine on the transom, the height of the anti-ventilation plate is an important consideration. Too low of an engine height will increase engine drag and decrease boat performance. On most transom-mounted applications, best performance is achieved with the anti-ventilation plate even or slightly above the bottom of the boat up to 1 inch maximum. Mounting an engine bracket or jack plate will put the engine aft of the transom. This distance is called engine setback and is determined from the transom to the back of the bracket. Whenever there is setback on a boat, there will be water flow off the bottom of the boat. As this water flows off the bottom at the transom, it rolls up. This water roll-up created by setback allows us to mount the engine higher. To get an idea of how high to mount the engine, measure the setback distance from the transom to the back of the bracket. A general rule in determining engine height when there is setback is that for every 12 inches of setback, the anti-ventilation plate may be raised 1 inch above the bottom of the boat. So if your bracket boat has 36 inches of setback, then the starting engine height is 3 inches above the bottom of the boat. For multiple engine applications on a V-bottom boat, the anti-ventilation plate height should be measured from the center of the gear case, even with the anti-ventilation plate. The inside of the anti-ventilation plate will be above, and the outside will be slightly lower than the V-bottom of the boat. Keep in mind that these engine height measurements are just a starting point. There are other factors, such as propeller selection, that affect a boat's engine mounting height. Aluminum propellers require lower mounting heights, whereas stainless steel propellers require higher mounting heights for performance. Now move your engine on the hoist closer to the boat. Before sealing the outer holes of the transom, check the steering system. Some steering systems will require pre-assembly on the engine prior to mounting the engine. Follow the manufacturer's installation instructions. Place a generous amount of sealer around the outside of the bolt holes. Move the engine into place to engage the lower mounting bolts just enough to place on a small flat washer and nut, hand tight. It is best to keep the engine backed off from the transom if possible to prevent the sealer from being smeared. At this point, check the engine clamp bracket angle to the boat transom angle. If the angles are mismatched, temporarily hook up the battery cables. Operate the power trim and tilt hand switch to adjust the angles to be the same. The top mounting holes on the engine clamp bracket have 4 different heights. With the engine hanging level, check the anti-ventilation plate height. Raise or lower the engine on the hoist to adjust the engine height to an engine clamp bracket hole that best suits the application. push the bolts through the engine clamp bracket and place a small flat washer and nut on each one. At this point, the engine is still being supported by the engine hoist. Evenly tighten all 4 mounting nuts and bolts to a torque of 31 foot-pounds. With your remaining 4 nuts, install one on each of the engine mounting bolts. These additional nuts are used as jam nuts. They also have a torque value of 31 foot-pounds. Repeat the procedure for multiple engine applications. On multiple engine applications, a steering tie bar is required. This tie bar turns the multiple engines at the same rate. The common factor between all tie bars is the engine toe adjustment. A good starting point when adjusting the tie bar is to have the engine centered. A tape measure and the required hand tools will be needed to adjust the tie bar length. To center the engines, let's first measure the front of the engines. We will measure the distance between the 2 engines from the middle of each gear case on the front edge, which on this boat should be 28.5 inches. Now we will measure the rear of the gear case centers using the center of the prop shaft, which is also 28.5 inches. If the distance at the front of the gear case is greater than the rear, the engines are towed out. If the distance at the front of the gear case is less, the engines are towed in. It is best to start with the engine even, or 0 inches of tow. That means no tow in or tow out. Whatever tie bar you choose among the many different ones available in the market, always follow the manufacturer's installation instructions. At this point in the video, we are going to jump ahead a few steps in the rigging process to cover the running tests relevant to engine installation. The next rigging step, component installation, will be demonstrated in Outboard Rigging Part 2. Before running the boat, there are some PDI inspections that must be performed. The PDI forms are available from Yamaha. Also, before running the engine, consult the owner's manual for the proper engine break-in procedure. With the engine set at 0 inches of tow, run the boat. As someone else drives the boat, watch the engine wake behind you. The engine wake is the propeller thrust coming up to the surface of the water. Each engine will make its own wake. You want to see the engine wakes meet between 20 to 50 feet behind the boat. If the engine wake meets beyond 50 feet, you will need to adjust the tie bar tow out. Do not exceed 1 inch of tow out measurement. In other words, the measurement at the rear of the gear case should not be more than 1 inch less than the measurement at the front of the gear case. It is best to adjust the tow out in 1/4 inch increments to achieve proper engine wake distance. If the engine wake is meeting under 20 feet behind, some tow-in may be necessary. You'll find that tow-in is rarely required. Most cases will need tow-out adjustments. Too much engine tow-in or out will affect water flow across the gear case. It may also affect boat performance. We will want to run the boat and perform some checks to ensure we have mounted the engines correctly for the intended application. It is important to fine-tune the engine and boat performance to give the customer a properly matched application. A good indication of proper engine height is determined with the range of trim, a water pressure gauge if installed, and a visual inspection of water flow around the gear case. Use all 3 of these indicators to determine proper engine height. Your setup test will have the most accurate results when the boat is loaded as the customer has intended, with the normal load of gear or equipment, fuel, and oil. Before running the boat, there are some PDI inspections that must be performed. Also, before running the engine, consult the owner's manual for the proper engine break-in procedure. The trim gauge is one tool used in determining if the engine is mounted too high or low. While cruising on plane, trim the engine up until propeller ventilation occurs. Propeller ventilation is when the propeller slips from excessive surface air. As propeller ventilation occurs, the engine's RPM will increase and boat speed will decrease. When this happens, trim the motor down until the ventilation stops. Note the trim range indication. If the trim range indication is less than half the range, the engine should be lowered one hole on the transom and then retested. If the trim range is at the upper part of the range, you may want to try and raise the engine one hole on the transom, then retest. The water pressure gauge test is very important, not only for engine height but also for possible water flow disturbance from the hull accessories, or tie bar adjustments. Yamaha has a minimum water pressure specification, which for 90 horsepower and larger is 11 psi from about 2,500 RPM and above. When gauging water pressure, it is not a matter of watching it on a straight run. You must also measure it in a series of maneuvers. These maneuvers would include different RPM operation, different trim angles on straight runs, along with different degrees of turning in both port and starboard turns. If the boat is equipped with leveling planes, trim tabs, they also need to be at different heights together and separately during different RPM ranges, trim angles, and turns. Finally, it is recommended that boats with powered jack plates always have a water pressure gauge installed. Be aware that catastrophic engine failure may occur at any time during this extensive testing if the water pressure falls below the minimum specification. Customer satisfaction is Yamaha's goal, and the best way to achieve it is to test each boat prior to delivery to the customer. This final step ensures that all your thorough rigging work results in a boat that lives up to the new owner's high expectations of a Yamaha. There are service and training aids that Yamaha offers that will assist you in performing the final quality control inspection of the engine. This concludes Part 1 of Yamaha Outboard Rigging. The next segment of our three-part series will look at component installation and rigging. We thank you for your continued commitment to customer satisfaction and for watching Yamaha Outboard Rigging Engine Installation.